everyone, my name is Lucky Chedupali, and today we are going to be learning how to find the zeros, x values, or roots of a polynomial using the Rational Roots Theorem. To start off, what are zeros? The zero of a function is the point x, o, where the graph of the function and the y-intercept intersect. Well, what is the rational root theorem? The rational root theorem describes a relationship between the roots of a polynomial and its coefficients. Specifically, it describes the nature of any rational roots the polynomial might have. We use this theorem to list out all the possible rational zeros of a polynomial function. Let's start off with an example. Let's go with f of x equals x squared plus x minus 30. We need to divide p by q, where p is the constant term and q is the leading coefficient. So, we need to divide the factors of both variables. Factors of p, or negative 30 in our case, would include plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and plus or minus 30. That's a lot of factors. Next, factors of our leading coefficient, 1, include just plus or minus 1. Now, we divide the factors of our constant term over the factors of the leading coefficient. That would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and plus or minus 30, all over plus or minus 1. That would just equal the numerator because we are only dividing by 1. So once again, our possible rational roots are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and plus or minus 30. If we were to set this function as 0, the solution would be the sum of our possible rational roots. So let's just do that. Let's start by writing the equation x squared plus x minus 30 equals 0. Since the degree of the leading coefficient is 2, it shows that there are two values of x. They can be real numbers or imaginary numbers. Let's start off by checking if f of 1 equals 0. F of 1 would be 1 squared plus 1 minus 30. So f of 1 would equal negative 28. And obviously, negative 28 does not equal 0, so 1 is not a function of this equation. Now let's try f of 2. F of 2 equals 2 squared plus 2 minus 30, which would be 4 plus 2 minus 30 equaling negative 24. Negative 24 also does not equal 0, so 2 is not a solution, is not a function of this equation. By function, I meant it is not a root of this function. Next, let's try f of 3. F of 3 equals 3 squared plus 3 minus 30. And that would equal 9 plus 3 minus 30, equaling negative 18. And obviously, negative 18 also does not equal 0, so 3 is not a root of this function. Now let's try f of 5. F of 5 equals 5 squared plus 5 minus 30. And that equals 25 plus 5 minus 30. And from that we get 0. 0 is equal to 0. So 5 is one of the roots of a function. One of the three would be one of the two roots of our function. Now we have to find the other root. Next, let's try negative 6. So f of negative 6 equals negative 6 squared plus negative 6 minus 30. And that would be 36 minus 6 minus 30. So that would equal 0. 0 equals 0, so negative 6 would be our other root. Now we don't need to check all the other numbers because we know there are only two roots. Now we have both the zeros of our polynomial. In this method we plugged in different factors, but in a future video I can teach you guys how to solve this by using synthetic division and only one factor. Thank you for watching my video. I hope you learned more about how to find the zeros of a polynomial using the rational root theorem.